As Max said, this is a talk on data pipelines, going from a monolithic architecture to event-driven microservices in Azure. I don't need to introduce myself again, but I'm Liam Jones. So why have I gone on this journey? So at my previous employer, we were working with a customer and we had an ETL solution, a data pipeline that was a couple of years old. We were working with Microsoft Teams data, so usage, compliance, governance, all that kind of stuff. And they introduced a webhook for call performance. So things like packet loss, jitter, all of those kind of stats. And they presented this data in form of a webhook because obviously they didn't want to persist all the records and all the calls for forever. So they pumped them out with the webhook. So this thing that we were building it wasn't a natural fit for the existing data pipeline we had. It needed to be extremely high throughput, much higher throughput than we'd ever seen before for any of our old reporting loads. Around about 16 million streams a day for our first customer. Again, a little bit of context, my previous employer had the opposite problem to Redgate, where they were huge enterprise first, really struggled with the small customers. So yeah, 16 million streams a day, about 155 a second. But the solution that I'm sort of showing you all today has been tested up to around about 50,000 streams a second. And then finally, arguably the biggest customer facing requirement was that this data would be real time. So as soon as a call had finished, you'd be able to get real time insights into any issues with that call, rather than waiting for your reporting schedule to come around and looking at it in 24 hours. It's just too late by that point. So agenda, going to cover the definitions of all the names in my wordy title. So data pipelines, monolith, event-driven microservices. We're going to look at some architecture diagrams for all of the above and pros and cons. Once we've covered off those things, we're going to look at how to split microservices and the problems that come from that in terms of reporting. So definitions. What is a data pipeline? There are various definitions, but in my opinion, it's very similar to ETL if you've heard of that term. So it's responsible for three things. First, it's going to extract some data from a source. So in my experience, it was Microsoft Teams, but for SQL Monitor, it's SQL databases, customer SQL databases. We then transform that data, apply business insight, logic, mapping from XML to JSON, all that kind of stuff in a transformational layer. And then finally, we load it into a destination, into the destination. This one normally catches me out because I actually think of it as saving data into a destination, but for whatever reason, it's called load. What is a monolith? So monoliths are tightly coupled solutions. So there's normally a single compilation. You test it all as one big thing. You can unit test inside of it, but if you wanted to do any sort of integration testing, it normally involves deploying the whole thing and subsequently installing the whole thing. Event-driven, so you kind of start breaking up the monolithic architecture by communicating via events. So you lose the chaining of calls. There's no direct invocation. Things become more loosely coupled, and they're made up of emitters that emit events and consumers that then subsequently consume the events, but the emitters aren't aware of the consumers and vice versa. What is a microservice? So it's also loosely coupled. It has individual compilations, therefore you can test functionality individually. You can therefore deploy individual bits, and you can also install individual bits per microservice. So monoliths in terms of data pipelines, what would it look like? So again, as I said, it's a single solution, many projects and one executable. So on the right-hand side here, we've got a source, we've got the cogs in the middle, which represent the monolithic solution, and a source destination data set on the right. The problems, it's all or nothing. So there can be bugs and unrequired features. If you only cared about, in my experience, if you only cared about call data, you may not want to deploy all of the workloads for files or for chat messages. But in a monolith, you have to deploy everything. So there can be bugs and unrequired features, and also unrequired updates, deploys, and testing of unrelated features or unrequired features for that particular customer. Large VM requirements, because it's a single install, you have to kind of scale it individually and put it all on one big VM. One problem can kill everything. So a problem in a particular feature that you're using could blow up the whole thing and you lose all of your feature set. And then also makes it harder to find problems. However, feature flags can mitigate some of this, and I'm sure you guys are all aware of how that works because we use them in Redgate. What does event-driven architecture look like in Azure? So you have functions and service buses. So, oh, sorry. 2 secs. Macy.
The joy of live, Liam.
Yeah. At least that's not pre-recorded now. The yellow lightning bolts are Azure functions, and the blue thing in the middle is a service bus. The one on the left is emitting events, and the one on the right is consuming events via the service bus in the middle. What does this look in terms of an actual data pipeline? There's lots of things on here. I'll try and talk you through it from left to right. So again, we've got a source destination, a source data set on the left that is emitting webhook events. That's being listened to by a function that's hooked up to listen to those webhooks, and that will be just like a call ID. There's been a new call. This is the ID. That goes into a queue, the requests queue. Then it goes into our extract layer. So it will then go back off to the source data set and grab the call for the particular ID that it's received. Sometimes webhooks work in that you get all of the data and you wouldn't then need to make that subsequent call back to the source. But that extract layer is responsible for going and getting that data. Also on the left, you've got a timer trigger because not all events are exposed as webhooks. There are still things that you need to do true ups with. So on a timer, on a schedule, you may trigger a request to go and get all of your users on a daily, weekly basis. And they go into the same request queue. The extract function will pick up those requests, go off and grab the data, and dump the raw responses into the response queue. So that's the E of the ETL. Then a transform function will be responsible for looking at those raw responses and mapping those into the well-parsed DTOs for that particular object, and then applying any business logic, any further transformation, calculations, all that kind of stuff, and dumping a nicely parsed, good to go object on the transformed queue. If we follow the top line, that then gets picked up by a load function that looks at the transformed queue, all of these lovely parsed DTOs, and dumps them directly in the database. The bottom part of that, so the new symbol there is an event hub. This is just sort of like an internal implementation detail of how Azure wants you to do things. That's there so that the stream analytics can only listen to event hubs. So that's also listening to all of these new transformed messages that are coming through the system. And then you can connect that into Power BI as live tiles. So whenever a new call comes in, it will literally appear straight away on your Power BI report. There's no need to do a manual refresh from the database, but you can still do that if you wanted. So the benefits, as I touched on just there, you can get real-time reporting. The E, T, and L are now decoupled, so you can do your extracting by itself. You could deploy auth if you wanted without worrying about your transformational and your load layer. It's easier, therefore, to find bugs because these things are decoupled, and the inputs and the outputs of the E, T, and L layer are all in message queues. So if you had an issue with parsing in your transform layer, you'll see dead letters. These dead letters, any errors will go into a dead letter queue, and you'll be able to find the input that was failing. So it's possible that your source data set had reshuffled the format of the raw object, and that was causing issues in your parser, and you needed to release an update in your transform layer to handle the breaking change from your source. If that were to happen, you could then replay events. So if that happened, we could update the transform layer, and then we could replay all of the dead letter queue back in, and we wouldn't have lost any data because they're all sitting there in the dead letter queue up to a point, because they can run out of space, but you can test and account for that. As a general theme of webhook, we can now listen to change events rather than get all events. I mean, there's big performance gains to all of that. And Israel is doing a talk on webhooks. slightly different to the concept that I'm talking about, but webhooks and how they work tomorrow at 11 a.m. And then all of the benefits around PaaS, so platform as a service, but I won't go into that because it's another topic in its own right. So the problems we have with this event-driven architecture is that it's still coupled in the solution. We haven't made any effort to split the solution out from a developer experience. And the database is still a monolithic entity. There's still coupling inside of E, T, and L. So all of my calls, all of my files, everything is still going through the same E, T, and L. There may or may not be a single dev pipeline, which means I can only test things in one batch. Everything has to be redeployed, everything has to be reinstalled, all of that kind of stuff. But you do now have many executables because you've split the functions up. So you could, if you want to test those individually, but then there's risk because your pipeline has produced a load of XEs. You could just test one of them, but now you don't know which ones haven't changed, and then you get into a whole world of pain around compatibility. Enter microservices. So these are around to try and decouple contexts that don't care about each other. You can now deploy, test, and install per context. And a lot of my previous experience has come from reading that book on the right there by Sam Newman. Would definitely recommend. So what is a context? So it's behavior that shares a common theme. So I'm touching on things like calls and files. These are domain contexts. These are things that belong together. So a call could have a stream, they're part of a call, and a file could have file content, which could be a subset of a file, but they're all related. And then you've got responsibility contexts that don't necessarily directly fit into a domain context. So how do we work about splitting these things? So first we need to identify these contexts. So this is normally code you work on per feature or per pull request. That's normally a good way to identify. So if I were to add in fact, we'll come on to this in a moment, and work out what you want to release. So your output should be the thing that you want to be able to deploy individually, and that will you can normally work back from that and figure out what your contexts are. Only split out one at a time, and review, learn, and improve, and then move on. So we'll touch again on the domain context. So here we have an example of domain context. So calls are their own thing, messages, files, channels, users, all different types of domain contexts. So in terms of our data pipeline, all of the stuff on the right is specific to the context, in that it's not generic. So once you've got your generic response object, the raw response from your source data set, you then need to start transforming this on a per context basis. It now has knowledge of the context that it's running in. It needs to apply transformations that are specific to the file or to the call. And again, with loading in your source data set, they're all going to be very in a schema style database like SQL. You're going to have a strongly typed schema, and your load layer needs to know how to efficiently save that data into the data set. So on the right, we can break those out, the transform and the load layer into contexts. And this now subsequently means that we probably need to start introducing some generic DTOs in the form of a NuGet package, because our contexts are going to be different solutions, but they all need to know about this raw response object. The stuff on the left isn't able to go into domain context because it's completely generic. So the webhook logic has no knowledge of the thing inside of the response. It's just responsible for looking at URLs and mapping them and passing them on. The same with the scheduler. It just needs to know what schedule it's running on, not the contents that it's going to receive. It's all very generic. I mean, again, with extract, these are all generic contexts, and can be left and split out by themselves. So why not transform and load? Because they aren't generic. They're tightly coupled to the domain models. So on the left, we can now look at splitting out responsibilities. So our webhook is responsible for webhook events, and the timer trigger is responsible for timer triggers. It's feasible that you could deploy to a customer that only were interested in loads that were from webhook, or vice versa. If our customer wasn't interested in the call webhooks, they needn't deploy the webhook because they just have the timer trigger schedule. and they didn't need to worry about that. And extract is something that all of our customers need to deploy, but it's something that could be deployed by itself. So if I made a change to auth or something like that, I could just deploy the extract responsibility and not worry about any of the solution either side of it. So yeah, how do we do this? One context at a time. So you try and work bottom up. So you look at splitting out your database first. That's normally where most of your coupling occurs, is in the database. You'll have objects that are very aware of the others, like foreign keys, all that kind of stuff. And you just need to make sure that you haven't got anything that's tightly coupling you in your database before you move on. Otherwise, you're going to be in hell. Once you've split out your database, so I've taken the call schema out of the big, massive monolithic database and create its own schema for it, I can then look at splitting out projects. Again, this will uncover hidden dependencies between projects. Keep going up, split out your solution. At this point, once you've got all of your stuff to do with calls out into its own solution, you'll probably need to introduce some shared NuGet packages as well. Review, learn, improve, and carry on. Because the first time you do this, it might not be right, but it's easier to adjust one incorrect microservice split than to try and reshuffle every single microservice that you pulled out hastily. So what would your pipeline look like for this? So now we have solutions per context. If I made a change to my call solution, I could edit my call solution, I could commit it. I could then build just the call solution and run all of the unit tests on it. I could release that independently, and I could test it independently. And now my customer can just grab calls. There's a new update, you've got a new feature, you've got, we've introduced a call duration column. You could just redeploy the calls solution and not worry about any of the other stuff, and that can all stay up, run, and you don't have to worry that you've introduced any regression. So yeah, I mean, this is the summary of what that looks like. The blue boxes are split out solutions. It's worth noting that the stuff on the right, the transform and the load, would still sit in its own solution, because it's most likely, if you were to introduce a new call duration, you'd need to transform it out. You'd then need to subsequently adjust the schema and make sure that it could load correctly. These are all things that you would do in like a single PR. To deploy that feature, you need to do all of those things together, and they can be deployed together. So they're like work units, and they make sense to be together. So these are my opinions. This is, I guess, my experience. Not everything is a fact. A lot of people will disagree with some of these things, but I guess let's have a chat about them. Drop the questions in, and anything that you disagree about, let's talk about them. So in my opinion, as a developer, I can work against a smaller solution, which means less cognitive load. I'm worrying about less things, therefore I can be more productive. I have smaller builds and faster feedback. As a developer / tester, I can now write more focused tests and worry less about regression. I can write integration tests and scale tests much easier because they're smaller units of work. And therefore I can also obtain faster feedback. So let's quickly touch on testing, because it's an interesting point. So now imagine this was all back in the big monolith. I can kind of like put some stuff in the front and expect some stuff in my database. What I can't do really very well is deploy bits of this and test them as functional units. But what I could do now is I could deploy just the extract layer in the external integration yellow box. I could just deploy that extract. I could dump a load of URLs on the request queue, and I can then assert, and I could be monitoring my response queue and see that all of the responses have come back. So I could write a little automated test that dumps a load of messages on the request queue and asserts your responses. I can then time, and I can write performance or scale tests for that individual extract layer, so that I know if I make any changes to it, I don't regress that extract function. If I made a change to the extraction layer, I wouldn't then need to go on and retest and performance test or integration test my transform or load layer, because I know that my responses are of the same interface or shape that they were before. I can do end-to-end testings per context and cut out the extraction layer. And I can just do single function tests as well. So you can kind of like slice and dice it as however you want, whatever makes sense to your solution. And I can also get metrics. I can get performance metrics for each and every step in here. So I can kind of identify where the bottlenecks are. As a support engineer, there's a reduced time to fix because of the smaller scopes, and I can better debug and repro because I can put stuff. If it looked like I was getting loads of errors on my transform queue, I could just dump a load of stuff, or maybe even look in the dead letter queue, look at the dodgy responses, put them back in there, replay them, and see what happens. Increased uptime and reliability as a result of smaller changes and fewer releases. So I'm just changing small little bits around the place, and I have greater configurability, arguably more distributed configurability, but more none. I don't know. That's you could argue which way that went. As a customer, I get all of the above. I also get my real-time reporting that I was after. And a nice side effect of this is that it's actually cheaper to host. So just quickly some stats on that. For our 16 million streams a day that we were doing, that's about 480 million a month, which resulted in about a terabyte of data being generated every month. In this solution, with the functions and the service bus, it was less than $200 for that kind of level. We did have a couple of $1,000 business critical SQL servers, but we can't really get away from that. Comparatively, even if I were to dump this on a 4-core VM, which it would just explode, that's going to cost me $300. It's already more. 64-core, maybe still might not even work. You're looking at about 5K for something like that to run, to maybe run something like this. But we didn't do that, so I don't actually have the concrete costs. But yeah, $200 isn't much for that kind of scale. Some of the cons. So incorrectly split context can increase brittleness and integration regression. So you could change one thing and inadvertently break something else because you've not split things correctly. You've got things that are dependent upon one another, but you've not made them dependent. You've pulled them apart, and that just doesn't work. You can get around that by correctly identifying your contexts. There's now more things to think about, more moving parts. So you could argue that. And you've now introduced loads of network calls effectively between your components. It's now no longer all in process. You're putting things onto a queue and they're going to have to get pumped out again. So you could argue that you'd have poorer performance due to that. Network security concerns and the cloud. Some people don't like the cloud. That's not really a microservice con, but it's kind of a con of the thing that I'm proposing in Azure. You can potentially do this on-prem with certain frameworks. So reporting. So reporting generally needs all of the data, and we've just split it all up. So that's not great. And this introduces a new problem for us to talk about. So it's termed database as an interface. So this is where ETL solutions are inserting stuff into a database, and your reporting products, Power BI or websites or whatever, are reading directly from that same database. Your interface between ETL and reporting is your database schema. So schema becomes the interface. The problems are, so one size doesn't fit all. ETL inherently wants quick inserts and loose coupling because of the benefits from microservices, but reporting wants quick reads and tight coupling because it wants to know about everything. And the problem with it being an interface is that your changes to your inserts, you may decide to readjust your schema for performance reasons. You can't do that because your reporting product is tightly coupled to your insert schema. So you've got to be really careful with breaking changes. So there are some solutions. Data pumps are quite a commonly found thing in this arena. And there's many levels of them, event data pumps and backup data pumps. Netflix have written their own project, I think it's on GitHub, it's open source, about how they take Cassandra backups and use those to pump into their reporting product. A multi-schema DB and Stream Analytics. Stream Analytics can also do this merging of data right out of the box. You connect your events in one way, and then it can reference all of your more cold stored data just out of the box. So yeah, Data Pump takes data from multiple databases and pumps them into one or many reporting databases, but with no mapping. Because if you started introducing mapping, then you just end up with an ETL there on your ETL product, which just doesn't make sense. So ETL remains loosely coupled. Reporting can now get all of the context. ETL can now pick its own database engine and tier per context. So I could decide to put all of my ETL into Cassandra or Mongo or table storage or whatever makes most sense. and I don't have to worry that reporting like Power BI needs to connect mainly into SQL. I no longer need to care about that. The cons is that anything too crazy could introduce a whole new level of ETL. So we didn't do that. We found that a good halfway house was a multi-schema DB. So you'd have multiple database projects so that you can test them individually, but in the real world, when it comes to actually deploying them all, you dump them all onto the same database, but keep them split by schema. ETL can remain loosely coupled, but reporting when they all get deployed to the same database, you can now report on all of them with not too much hassle. And then you can split your load concern by having replicas, read-write replicas. So your ETL layer inserts into maybe a higher tier of the database, and the backup replica could be a lower tier because it just needs to look at reporting. Cons, they both have to share the same database engine, so I can't do the Cassandra versus SQL thing. And there's slight risk in that if you're deploying multiple database projects into a single DB deploy and not testing that anywhere earlier, you're only going to find out those kind of problems when you go to production. So in summary, an event-driven architecture, an Azure platform as a service, components provide improvement over a monolithic VM deploy. Pros and cons still, as we discussed earlier. Microservices can then layer an additional layer of benefits on top, but to do it properly, context is key. If you split it out wrong, it's going to be so painful. Think what you want to deploy and work backwards. And database coupling is an inherently hard problem to solve. Where does this work at Redgate? So the reason for this talk is I had a chat with Jeremiah and we got chatting about some of these bits. But I guess my initial thoughts on this is that SQL Monitor is very much on-prem, and we look at on-prem databases and they're normally distributed. This is very much looking at cloud source providers. And SQL databases, the stuff that we're looking at, there probably aren't many webhook events, if any, to get those. It's very much a polling product. However, on the flip side, I think this is what Israel's talk is going to be about, is that alerts are events. So introducing the eventing layer into SQL Monitor could be a very good idea for those kind of alerts thing that would make that problem a lot easier to solve. Related topics, I mean, there's loads of stuff. For performance reasons, you can get into service bus batching. You can start batching your messages through the system. This isn't really related to data pipelines, but in other things, there's a concept called Saga that looks at enforcing transactional integrity between microservices. And event sourcing. So this is putting all of your events down into the database, and then you can then read and replay them all the way up. So you store all of the events rather than collapsing them. That's called event sourcing. And maybe a way to get around the on-prem problem is to look at a platform called Kafka. They seem to be pretty much the market leader on event-driven systems. So that's another one to look at. I think that's everything. I timed that quite well. I don't think there's anything after this, so I think hopefully, Max, we've got time for some questions.
We do, yes. We can afford to overrun by 5-10 minutes. So we actually have some questions in the chat. So let's start in order, and we'll start with a question from our very own morning chat star presenter, Kendra. So Kendra is asking, could you talk a little bit about the process of untangling tight coupling in the databases? A lot of our DevOps customers run into this problem.
Yeah. So, well, can I? It depends how far you want me to go into it. Let me flip back to the slide. It's all about identifying those domain contexts, and for the kind of thing that I was doing, it was quite easy because they were normally the endpoints that we were querying. I guess for me, the biggest thing is what if you were to change something, what's the smallest subset of components that you need to work with in order to make that change? If you need to start, basically, you don't want to be touching more than one context in any feature request. And if you do, then that's probably a sign that you've got your context wrong. That you should be able to deploy a feature and only touch one context. Is I guess how I'd look at it. But to get to there, I mean, it's a hard problem to solve. You need to be really aware of how your system works. I don't think there's any right answer to getting to that. it's just whatever eventually makes sense. You won't get it right first time either, I don't think. It's kind of like a reiterative and get better and improve kind of thing. Sorry, I don't really have a better answer for that. It's a hard problem.
Any follow-up question, Kendra? Feel free to unmute yourself if you want to.
Oh no, that was a great answer. I kind of knew it was tricky, like a big question.
Great, thanks. Right, moving on to the next question. So we have a question from Sybil around more projects, how this project went. So what was your biggest pain when doing this project, and is there any things that you would have made that project easier for you and your team?
I think it was a journey. So the kind of the order of the slideshow that I presented today was the order that we went. We kind of had to go to the webhook style event-driven thing because our old existing monolithic solution just wasn't geared up to kind of handling those events. It was set up as a very much a scheduling thing, and everything was tied to a schedule. To kind of like introduce anything there just wouldn't have worked. So we kind of went greenfield and came up with this Azure architecture just for the calls payload, and left all of our existing functionality back in the old solution, and then started bringing across and migrating old data sets across into the new Azure platform. I guess where it would, there's risk in going directly straight to microservices. We could have possibly saved some time going directly to the microservices and have like the transform layer, the per context on the right. We didn't go to that straight away. We just had a generic transform and a generic load layer. We started running into lots of scale issues because they just those things needed to be able to be scaled separately. Like we had all these calls coming in at silly records per second, and then some of the things like users that were much slower, and you wanted to be able to scale those things individually. So maybe if looking back at that, we could have maybe identified that earlier. But also you've got to be very careful that you don't try and optimize before it's actually a genuine problem, because you end up over optimizing, and there's a whole world of problems there as well. So I don't think we got to the right place. Maybe we could have got there a little bit quicker, but I think it was our risk versus reward kind of balance that we picked.
That's good. All right, I've got the last question. Given the amounts of events going in, have you considered the different stores and just pure SQL? So something like Azure Synapse, for example.
So on the right hand side, because of the data pump stuff, we didn't ever get to the stage of being able to split away the SQL stuff from split the ETL and your reporting layer. So we just kept it in a SQL database because that's what we were kind of used to. Did we look at Synapse? I don't know if we did. There were a few that we kind of looked at, but we just stuck with SQL because it wasn't an issue. We knew how it performed. If we were brave enough to kind of take that next step and split your ETL from your reporting databases, then maybe we would have, but we were tightly coupled to Power BI. Maybe Synapse worked with Power BI, but no, we didn't explore anything on that kind of reporting side. What we did do is on the throughout this sort of picture dotted around, everything before the SQL database, we backed off to lots of table storage stuff. So maybe that was worth explaining. So what we do is that we wouldn't. So for example, the transformed queue. When we transform something, we wouldn't put that transformed message directly on the queue because of payload size. You didn't say there was a call with like with however many people, or a big conference with maybe 1,000 people on it. You weren't sure how big that message was going to be. So we'd back off to a bit of blob storage. We'd put the parsed object into a blob, and then we'd pass the ID via the queue for the load function to then look and grab the queue. So you were only ever passing references. You were never passing the actual object. So dotted around this is all blob storage and table storage for configuration, like real cheap storage options. It's only when we got to the reporting layer that we backed off to SQL.
And slightly related question to, have you considered anything else than Azure, like AWS, for example, and you're a PaaS supplier?
We have done solutions in AWS, but we were I guess very much coupled with Azure because of like customers' security concerns, because all of this data, Microsoft Teams, is already in Azure. They wanted to keep everything inside of their Azure tenant, so the data was already in there. They didn't want to kind of like migrate it over to that. They actually had less concern staying in this customer never wanted cloud before, but because Microsoft moved their Teams up to the cloud, whereas Skype for Business used to be online, they'd rather keep all of it in the cloud than kind of like go over the wire. So Azure was kind of like the no-brainer for us in this particular scenario, but there's no reason why you can do this in any other platform. And we didn't compare it for any other reason than kind of like customer security stuff.
Okay, well, thank you very much, Liam. That was very interesting. Lots of like virtual applause. And if you, oh, sorry, we got one. Simon's a bit late in posting a question. We got one question. Sorry, I'll do you mind answering your last question? So we have one from Simon around, were you merging many different sources, or was it a fairly linear flow from one source?
It was all graph that Microsoft provides to get all this Teams data. So yes, yeah, there was only, I guess, one source, multiple endpoints, and I guess you had the webhooks coming in one style, and the scheduling coming in a slightly different way, but it was all hitting graph.microsoft.com.
Cool. Right. Well, this time I'll wrap it up. If you have any more questions, feel free to reach out to Liam on Slack. And yeah, thank you again, Liam. That was very interesting. And thank you everyone for attending. Next, we'll have this afternoon at, we'll have at 1 o'clock, Everything You Want to Know About Agile by Ben Mancini. So thank you very much and enjoy the rest of Level Up week.
Cool. Cheers all.